Okay, so first of all, this is the pre-talk bit. The first thing to note is that whenever people talk about AI bias, where does AI bias come from? It comes from us. I want you to look at the room and notice the bias. The stairs are there, therefore all the people are over there. Hi. There's actually quite a lot of space over here. The other thing is I'm surprised to see any of you. I've had so many people come up to me and apologize for not attending my talk that I thought there would be nobody left and this would just be a quiet conversation with myself. And I have no problem talking to myself, but you know, I'm glad you stayed. Paris, Friday, last thing. Yeah, I'm impressed you're here. Other things we're going to set the expectation. What are some of the things in the talk and some of the things not in the talk? Some of the things in the talk, all photographs except one were taken by me. So, you know, no stock imagery, no AI-generated imagery, all the rest of it. So that's what's in the talk. You're invited to guess which photograph is not one I took. Okay, I'll be testing you later. But also, I'm not going to say whether or not it's because they melted, because it's been a long time since yesterday. I'm not going to say whether it's because I have found a new revenue stream in iceberg consultancy. Please see me afterwards. I have some thoughts on this. You show me your icebergs, and I'll tell you whether or not they're legit. You know, this is my plan B career. We might hit a few rocks, but there is a boat. But you know, with that's I want to manage the expectations, but I'm quite happy to discuss icebergs afterwards. Now you might say, well, hang on, come on, Kevlin, that's not really fair. I turned up expecting icebergs, but this is clearly an act of neglect on your part. And you're right, I am going to talk about neglect, just not iceberg neglect. I'm going to talk about technical neglect. I'm going to explain what it is. I'm also going to give you a little bit of a journey, because I also want to talk about the words that we use. And some of the words that we use are also mangled up with slashes and ats. We live in an era of fragmented social media, and I have no idea where I am. You can find me everywhere. So, you know, look for the internet unique name. Sometimes I'm lucky and it's Kevlin. Other times you have to go the full name. But yes, you can find me posting in a number of different places. Now, one of the things I quite enjoy about putting together a talk is the happy accidents, the serendipity. The number of times people always sort of say, oh, I finished my talks weeks in advance. And I'm kind of like, no, that's not what I do. The only reason this talk was ready is that I've already done a version of it, except that it wasn't ready. I was just going through a file of things the other day, and I found something that I said, which I actually said, and I thought, wow, this is good. Good timing. The words shape what we think, so if we choose the wrong words, it will take longer to discover the thing that matters. And I thought, wow, that sounds, you know, if that hadn't been me, I'd go, that's a really good quote. Now, that was in response to somebody else. We were generally talking about a number of points. But notice, specifically what I'm describing here is, I'm not simply talking about the idea of sort of, certainly not language determinism, a little bit of language relativism, but it's the idea that sometimes we will get there in the end. Sometimes it just takes us a little longer. We get distracted by our vocabulary, and our vocabulary starts forming movements, and it becomes used. It becomes currency within and between our teams and across our organizations. And specifically what I want to refer to is a little thing that we kind of confuse. Cause and effect. What do I mean by this? I mean, how can you confuse cause and effect? Humans do it all the time. We notice coincidences and try to relate them. And sometimes there is a correlation, and sometimes there is a causal relationship, and sometimes we get that causal relationship back to front. We misattribute things. This is common vocabulary in modern development environments. It's common enough that it's actually, in some organizations, it's escaped the technical teams. It is a language, it's a term that people throughout the organization may have some familiarity with, technical debt. And a lot of teams say, we have a technical debt problem. That's an effect. We're going to dig into this. It's certainly, there's something there, and it may be contributing to be a problem, but it may actually be a manifestation of a problem. In other words, it's an effect. What is the cause? Well, what I'm going to describe today is that one of the main causes, and I will clarify what I mean by technical debt as we go through, and I'm missing a word when I say technical debt. If you listen closely, you can hear the silence before it. It's written in silent character. Well, honestly, I've been reading French signs for the last few days. There's a lot of silence in those words. Yeah, that's what I learned at school. When you learn French, that bit's silent, and that bit is not pronounced the way you thought it was. Whereas if you've learned English, none of this is pronounced the way you thought it was. So, it's a fair trade. Honestly, French could be so compressible. Yeah, but that's the thing. I am using a silent word before technical debt. But I want to focus on technical neglect. And why is this a challenge? Or rather, why is it that we are not identifying this and talking about this more? Because neglect is a thing that doesn't happen. We're very good at seeing things that do happen. We're not so good at seeing things that don't happen. Yeah? Did you notice that thing just now that didn't happen? Yeah. Exactly. So this is the issue. It is hard to see. Now, we have an example of neglect here. What happens when nobody looks after something for 35 years, where there's a place where there's no human habitation for 35 years? Well, this. Yeah, it's a thing that doesn't happen. It's a thing called maintenance. So here's the boat. You'll notice the icebergs have already melted. And I want to talk about this boat. Well, actually, not this boat. This boat was actually, if I remember correctly, it was intact. It didn't have any holes in it, but let's just pretend it ran across a small iceberg, and there are holes in it. And you are out on the water. And I want to solve this problem two ways. I want to solve it the way as software people we would solve it, and then I want to solve it as everybody else on the planet would solve it. Okay? So, there's a hole. There's water coming in. The boat is sinking. What are you going to do? Well, actually, with software developers, there's a couple of different responses. And it depends on your organization. In certain organizations, it's, well, let's have a meeting about this boat. When can you do? Well, I can probably do next Monday. Okay, well, yeah. I think we've got about 10 minutes before we go underwater, but let's schedule a meeting for next Monday. So there's those organizations. They're probably running safe or something like that. Then there are other organizations where what happens is you have lived with this for so long, the boat is always sinking. This is how we live. This is software development. This is habituation. This is learned helplessness. We just watch it. Yeah, this is what boating is. Then we've got the proactive crowd. Yeah, I see you. You're here because you're at a conference. You're going like, yeah, we're going to empty the boat. We're going to have a workshop, and we're going to empty the boat. We're going to work out the most effective way of emptying the boat. We're going to keep that water coming out. I noticed that half the Dutch people have already fled. They are the people you need to speak to about kind of emptying things out. This is good. But you're going to empty out the boat. That's what you're going to do. Brilliant. The rest of the population will go, hey, there's water coming in. Maybe we should stop the water coming in. Crazy idea, right? Now, the funny thing is that this, I have seen this more than a couple of times and brought home vividly in a couple of organizations where I visited and I ran a workshop on, what to do with your legacy code. Let's create refactoring paths. In other words, let's describe the journey so you can make it real. If you can visualize the journey, it makes it a little bit more real. It's like, here's how we're going to get out of where we are now. And implicitly, I had made an assumption. And that's the interesting thing. Assumptions are invisible until they are pointed out to you or until they are contradicted. And there was, and one organization was actually very effective. They said, oh, yeah, that really helped. That really helped. And it made a difference. They addressed their unmanaged technical debt. They addressed some of their legacy issues. That's great. Then a couple of years later, hey, we've got that legacy problem again. Because it turned out, although they had learned what to do with it, they hadn't learned how not to keep creating it. Yeah, they reached a kind of steady state. The water is still coming in. So we're going to go on a little journey. I'm going to take you back to 1980. Meyer, Manny, Lehman. It's a classic paper, this. I mean, I know you have been at this conference and people have been recommending papers and books and papers. You are overwhelmed with this. That's why you have a weekend, you know. But I would like to offer this one to you. And also there is, I believe, somewhere there is a summary of this paper by Adrian Collier. It's just sort of a couple of screens worth. Programs, life cycles, and laws of software evolution. This is very much a culmination of Lehman's work in the 1970s. So we might say this is 1970s observations, 50 years old at this point, really. And what I'm interested in is this observation. As an evolving program is continually changed, its complexity, reflecting deteriorating structure, increases unless work is done to maintain or reduce it. Now, I find this fascinating for a number of reasons. There are a number of words it avoids, partly to do with things like time travel and the fact that we don't really have it available to us. Doesn't use the word legacy, doesn't use the phrase technical debt. But what I find interesting is this very simple observation, and let's be very clear, the scale of software systems in the 1970s was significantly smaller. Certainly, software was becoming more and more pervasive, but it was nowhere near as interwoven into the fabric of everyday existence as we have now. And you did not have anywhere near as many software developers. And yet these observations, this idea about, hey, guess what? This is a bit harder than we thought. There was an assumption. There were a number of assumptions. In fact, Laurent, in his session before, kind of pointed out that there was an assumption once upon a time. It's like, hey, we didn't expect bugs to happen. That was a real surprise to the people who first started developing software. Okay? In fact, we can even go back to Ada Lovelace, who managed to find a couple of bugs in Charles Babbage's code in the middle of the 19th century, which she noticed these when translating his talks from Italian. It's just like, wait a minute, there's a bug there. But you know, this is the whole idea. We were surprised by the level, the defect level. But the thing that also surprised us is when we have code that sticks around and we have to go back to it and change it. And it turns out that the changes are surprisingly hard and become harder with time. And this observation here is he's saying, as an evolving program is continually changing, its complexity reflecting deteriorating structure. He is saying, he's not saying you're doing bad development. This is the really interesting thing. It's not to do with you have done bad development. If you have done great development, then it probably deteriorates at a slower rate. But he's actually saying that it's built into the very process of change. If you change something, its overall quality, to add a feature or modify a rule or something like that, there is a chance that its overall quality will deteriorate unless you put extra work in. And this is implicit in the universe. The idea is that we often, when we make any change, we are upsetting something that, for the sake of argument, already works. We're upsetting an equilibrium. Let us just say we have the perfect code. Just close your eyes. But not too much. I don't want you to sleep just yet. Close your eyes. Imagine that. It's the perfect code. So I'm going to give you this kind of beautiful baseline start. This is the joy of thought experiments. We can imagine the impossible. But now, you're going to make a small change. The thing I'm going to have to point out to you at this point, just in case you forget, is you are human. Humans have this thing called attention, focus. It's a visual metaphor that we use. By definition, when we are focusing on something, it means we are actively or inactively not focusing on other things. We have taken our attention away from everything else. You cannot focus on everything because that's not focus. Okay? So by definition, you are withdrawing your attention from all of this. Unless you are changing one tiny, tiny line of code, and that is your whole system, one tiny, tiny line of code, by definition, you are not paying attention to everything else. You have a simplified understanding of it. And it's only later, either you or a colleague will observe, by changing that, we no longer need this. And it depends what your feedback cycle's like. It might be by changing this, you've actually caused a bug, and then your tests will pick that up. Or you've actually changed the style or the paradigm of the code, and you moved it in a new direction, and perhaps that's a direction you'd like to embrace to make your code more consistent in that new direction. The point there is, by definition, you've upset something that was already quite happy, and you've done something that was done with the best intent, and perhaps you applied your best practices, but by definition, it's a system, and most of it is not in your attention span. Deterioration. It is very much, and we're used to this in the real world. You know, I go to, so I'm at home next week, and I'm gonna cook a couple of meals, and I'm not gonna, the way I'm gonna do this, I'm not gonna go and declare to my wife and younger one, oh, I'm just gonna go to the kitchen to make a mess. I mean, there will be a truth in that, but that is not my goal. I am going to go to make a meal. And I can be as tidy as I want, but there will still be things that need to be cleared up. It is a side effect of doing this. So what Maya Lehman is saying is, in order to maintain the integrity, the quality that you have to put extra work in addition to what you were already doing. And this is as true in an information system, because it's still a system, and it still has connections and assumptions, and well, we still have to do something about it. Now, what I also find interesting here is the word maintain. It's actually using maintenance correctly. And what do I mean by that? Maintenance is a word that we have taken on board. We use it extensively in software. But we normally use, maintenance depends on the organization. Maintenance means a variety of things. Maintenance means bug fixing in some places, in a lot of places. It's like, well, are you maintaining it? It was always broken. Yeah, it's not maintenance in the real world is to do with wear and tear, that things wear down the more you use them. That's not what's happening. The idea is that perhaps when we interact with the code, we are upsetting it. To maintain its original, we need to put extra work in. But that's not what we're saying. Is that bug? Maybe that bug's been in there a year. That's not maintaining it. You're doing the exact opposite. You're actually creating something that was not there. You're not maintaining a thing. You're eliminating a thing. Alternatively, in many organizations, maintenance just means software development. Yeah, it's just like, oh yeah, we've done the initial release. Okay, what's everything? What's everything else? That's software development. It's all software development. Yeah, so it depends. So here's the thing: we've taken this term. So let's kind of understand this one. Let's dig around and find out, because the point is that maintenance is a metaphor. So I'm going to refer to the Oxford English Dictionary. The OED is an interesting thing. Specifically, it's interesting because if you want to find out how a word is used, this dictionary is entirely useless to you. This is not a usage dictionary. A usage dictionary lists things that the most commonly used term, or most commonly used version of a word, will be the first, and then the next most common, and then the next most common. This is an etymological dictionary. It will start as far back as the word starts. So for some words, you go back 1,000 years. And if you are a word nerd, this is fantastic. It's just like, oh my goodness, I didn't realize these connections between the languages, and it went through these different forms. If you are trying to find out, how do I use this word correctly, this is not the dictionary for you. I am a word nerd. I have dictionaries, physical and, believe it or not, on DVDs. I only have, just to keep them so I don't have to go and subscribe to stuff, so my movements are not being analyzed. The only problem is that we only have one optical drive in the house, and it looks like a piece of history. Anyway, what's the word I want to look up? I want to look up metaphor. The figure of speech in which a name or descriptive term is transferred to some object, different from, but analogous to, that which is properly applicable. Okay, so the term metaphor is what we use extensively. We use metaphor in software all over the place. It comes originally from the Greek, metaphora, meaning literally to transfer. We are transferring meaning. And the point about this is we are basically saying, hey, here's something that is abstract or complex or unfamiliar. I would like to explain it to you in terms of something that is concrete and familiar. So the things you understand here, I'm going to outline points of correspondence. And you go, oh, yeah, now I get it. Okay, I understand. Now, this is important because by definition, this means that no metaphor can be perfect. It's not a perfect mapping. If a metaphor is actually perfect, then it's not a metaphor. It's identity. Okay, so if anybody ever complains, oh, this metaphor is, it's imperfect. Well, yes, of course it is. But we can discuss the degree of imperfection. But the thing is, in software, we do this all the time. Just look through your code base and look at all the names and the concepts. So on my laptop, I've got a desktop. Actually, the difference between my real-world desktop and my laptop desktop is tidy. My real-world desktop is a mess. It is chaos. And when I sit at home in my office behind my chaotic desktop, I have a window in my office. I also have windows on that. What can you do? It gives you a systematic vocabulary. Metaphorical entailment gives you the vocabulary. Oh, you open and you close a window. You don't run a window. That's the language of engines, start and run. We do that with code. We use the engine metaphor quite a lot. Crash, yeah? So in other words, it gives us a system of vocabulary. Of course, it's not perfect. I mean, how much does it cost to resize a window in the real world? Yeah? It's not cheap. My wife and I have done it. It's really cheap on that thing over there. So we understand this. We use metaphors absolutely everywhere. We're talking about file systems, networks, the works. And this idea that metaphors are deep to the way that we even think was really catalogued and captured very nicely by this book. You can kind of tell how old it is, 1980. Magic year, that, clearly. But nobody produces book covers like this. Lakoff and Johnson, Metaphors We Live By. And they basically said, hey, metaphors, this is not just poetry. This is actually systemic to the way we think, how we use prepositions and how we have ideas. The very fact that you might say, oh, you see that village in front of the mountain? Mountains don't have fronts. Just pause for a moment. Mountains do not have fronts. People have fronts. We're relating to the mountain as if it's a person. Mountains don't have fronts. They're perfectly symmetric and they don't care about you. So the point here is we are using a lot of equipment to give ourselves an understanding of things that are potentially difficult to understand. The essence of metaphor is understanding, experiencing one kind of thing in terms of another. Now, that doesn't mean that we can't say what is a good metaphor. And I wrote a piece for O'Reilly Radar a couple of years back on exactitude and technical debt, where I outlined 3 qualities of what makes a metaphor good. To be considered good, a metaphor has to offer a number of points of useful correspondence with what is being described. Because if it doesn't do that, that's not going to be helpful. Another quality is that it should not have too many obvious points of conflict. Okay? If something essential to it is distracting everybody, then maybe that's not a good metaphor. Yeah, there will always be things that are true of this that are not true of this. But if these are the dominant characteristics, they're going to get in the way. They're not going to assist understanding. They're going to be obstacles to understanding. The third one, however, is an interesting one, because it's very, it depends. The third quality of metaphor that makes it effective is familiarity to its audience. It depends who you're talking to as to whether or not something is effective. And that audience can shape this. So when talking about the issues of code that we might find in legacy code bases, one of the ways of understanding it that I always found really helpful was entropy. And that one worked for me and a number of other people at the company that I was at, because honestly, half of us had degrees in physics. So entropy, yeah, that makes sense. And then you talk to somebody who's a skilled developer and does not have any kind of background in physics or information theory or anything like that, and you say, oh, it's got high entropy. It's like, what? So now you are in the position of, oh, let me explain this abstract concept that you don't understand so that you can understand this abstract concept that you don't understand. This is not a good mapping. But it does mean it's audience dependent. It also tells us why it is that technical debt is popular, because debt, it's a shared experience. It's a cultural experience, and some cultures more than others. So here's an interesting one. Blog by Steve Freeman. This blog kind of jumps in and out of existence. But Bad code isn't technical debt, it's an unhedged call option. Okay, who knows what an unhedged call option is? And there you are, fingers on one hand. Right, that, and this, I love this observation, somebody else. For people in fintech, this is a really interesting analogy. And that, that Jonathan Caston made this observation, and that's great. If you are in this space, then it's just like, I'm with you. You're speaking my language. You've given me a mental framework that I can quantify something abstract and unfamiliar, and yeah, I already deal with this. This is great. For everybody else outside, it's just like, can we go through the whole call option thing and hedged and unhedged? That's not a useful framework for us. Doesn't mean it's necessarily bad, but it's not effective for the larger audience, which is why sometimes, and I've had discussions with people who sometimes say, oh, in our domain, we've ended up calling it this. And somebody messaged me from the medical domain, and they had but they had to explain what their metaphor was, because I didn't understand it. But that's the point. You may find something that is more suitable to you. But for a general audience, this is not useful. So let's talk about some other words. Let's go and raid the dictionary. Legacy. So let's talk about legacy, because this is a word we use quite a lot. Now, so we've got designating software or hardware which, although outdated or limiting, is an integral part of a computer system and difficult to replace. Okay. So here's the thing. It depends on your age. It depends when you entered software development. If you are of a certain age, you're going to go, wow, 1989, that was really late. If you're of a younger age, you're going to go, yeah, that's always been the case. It's like forever. Yeah? I come from the former category. I am astonished how late this term actually entered use. I know I was using it in the early 90s, and it's just that we didn't have a word for it. People did not think they said stuff is unmaintainable. They didn't have a systematic vocabulary for it. It wasn't properly recognized. It was, oh, we must have this because of some deficiency. Rather than actually, this is kind of intrinsic to the way that a bunch of people doing a bunch of stuff happens. There are other definitions. I think one of the ones that people informally use. I have done workshops on this. I always tell people, give me your definitions. Code that someone else wrote. Sometimes people are really kind of like, code that I wrote yesterday. Sometimes they're very, they appreciate that. They understand their own limitations. We're going to come back to this one. Now, this was an interesting one from Angel Sierra, which I saw recently, and I thought it was interesting for a number of reasons. Legacy code is often defined as code that makes more design decisions than the team working on it. Now, this is interesting for two reasons. Wow, that's a really good definition. I love that, because it talks about a balance of control. The balance of control is effectively outside the human part of the team, okay? The code has made the decision. The code is sitting there at your meetings. Oh, it's quiet in the corner. And everybody says, yeah, we've got this plan. And the code's sitting there, The code has the ultimate veto. That's when you have a legacy system. You've got some great ideas. You've come back from a conference. You are fired up with energy and concepts. And the code's going like, nah, not today. Oh, that's legacy. But the other thing is that although Angel says legacy code is often defined, actually, I've never seen this definition before, and I Googled it. So, I thought, this is great. I wish I'd come across this before. This is fantastic. But I also like the fact they went on to say, could we define a legacy process as one that makes more decisions on how a team functions than the team itself? It's like, oh, okay. This is very rich as a source of thinking. So when we're using this word, the curious thing is that legacy has been inverted. We often talk about legacy by default in English as being a very positive thing. A person leaves a legacy. This is what they leave behind, and people think positively, yeah, they're great ideas, they're great wealth, they're great whatever. In software, we don't mean that. The default meaning of legacy is not a good thing. We have to, if we mean it to be good, we have to put words like good in front of it, just to remind people it's the other way around. So we've done a little inversion here. But stumbled across this report last year before, I think it was published a couple of years ago. US-based. So over $1 trillion to keep the lights on. Legacies drag on productivity. And you can find a number of different examples around describing the situation, but I found this one quite interesting in terms of the numbers. In 2019, a US Government Accountability Office report found the federal government spends more than $100 billion on IT and cyber-related investments annually. So what? That's just big numbers, okay? We don't know if it's good or bad. Now it gets interesting. Of this amount, agencies typically spent about 80% on the operations and maintenance of existing IT investments, including legacy systems. Oh, that's quite a lot. But it gets more interesting when we break down the next set of numbers. On average, 31% of an organization's technology is made up of legacy systems. Now, depending on where you work, this either seems really low or incredibly high. I found it quite low, but let's just go with the numbers. I'm just, given these numbers and the sample organizations involved, is you're going like 31%, that's not a big deal. Okay, what's the problem? Well, if it's disproportionately consuming the money. It's like, oh, right. So less than 1/3 is consuming potentially 2/3. Ah, that's the problem. It is costing more. That boat is sinking, isn't it? Legacy technologies hamper efficiencies and restrict growth in an estimated 88% of businesses. So that's the thing, is it's preventing you. It eliminates your options. It doesn't cause you to not be able to have a business. But what it does is it's like driving with the brakes on, okay? You're in the wrong gear, you are going slow, and you're still making some kind of progress, but it's more wasteful, it requires a lot more effort. That's what's going on. So we need to talk about the creation of legacy code. How does it happen? Well, specifically, I'm not going to talk generally about the creation of legacy code. Well, we'll do in a couple of minutes. But this is taken from, well, sorry, it's 2024. Is this even a talk if I don't mention AI? Of course, there we go. It was all the use of AI that melted the icebergs. Yeah. The practical consequences of using LLMs to generate code is that many developers will find they have unwittingly moved themselves into a role they were probably trying to avoid. They have automated the creation of legacy code because it was somebody else that wrote it, right? You didn't write it. So you have just created legacy code. Well done. I'm going to use a correct football metaphor. It's an own goal. You just scored a goal and it was yours. It's not the other team's, it was yours. And had redefined their job as debugging and fixing such code. Now, this is really interesting because that's I said this just over a year ago, April 23. And I kind of like put this out there. I'm not saying that everybody's doing this. Notice I say many. I reckon, I'm going to pick some random numbers. I have no evidence of these numbers just at this point, but I'm just going to be very generous, and I'm going to say 10% of developers are not in this. 90% are. 10% are doing a really good job. They understand exactly what it is that AI can and cannot give them. They are using LLMs to explore things, to get suggestions. They are integrating them into their own thinking. They're not just going, yep, copy, paste, or just put it in straight into my source file. They're looking at it deliberately. I know what I'm expecting. I have already written tests. And I'm evaluating. In other words, human in the loop. I'm using it to give myself an advantage. The problem is that most people are not giving themselves an advantage. They are giving themselves a disadvantage, and they don't know it. They are getting the sense that, oh, wow, I'm being so productive because it's generating so much code. Lines of code, not a useful measure. They are getting a sense of progress that is a lot like, well, when you sit in a train and there's another train adjacent to you, you know this feeling. The other train moves and you think you're moving. Yeah, that's called vection. So what we're having is a lot of vection, which also creates a lot of vexation in the long term. So there was an interesting, so this is the thing that I found interesting. I said that last April. January, there is a study from GitClear about coding on Copilot. 2023 data shows downward pressure on code quality, 150 million lines of analyzed code, and projections for 2024. So I thought, okay, this is a fairly decent data set. But what was fascinating is like it's there in the subtitle, downward pressure on code quality. Basically, they're saying, okay, here's the AI era, and woo, here comes the code churn. We find disconcerting trends for maintainability. Oh, so if you're wondering if your job's safe, it's totally safe. It's absolutely safe. As long as you're a legacy code programmer, yeah, and create your own legacy. Yeah? Code churn, the percentage of lines that are reverted or updated less than 2 weeks after being authored, is projected to double in 2024 compared to its 2021 pre-AI baseline. There's a small number of people who are really absolutely tearing this one up and doing a great job and getting such an advantage because they understand exactly how to work with the tool. And there's a lot of people who are not, and unwittingly so. You don't always see the problem. We further find the percentage of added code and copy-pasted code is increasing in proportion to updated, deleted, and moved code. That's a really interesting observation that they make. They're not just looking at code churn. It's the characteristics of how do I know that a refactoring or a change is good? We often characterize things by, oh, well, yeah, we deleted this. We moved it. A lot of good refactoring is about moving responsibilities around. It's just, oh, that doesn't belong over here. That's duplicated over here. Maybe there's an idea we missed that's in the middle. Let's move that there. Create a new concept. There is a class that is sitting there or wanting to be noticed. There is a responsibility kind of lurking between these two objects that wants to be reified, to be made real. And so that's what we're after. There's a lot of movement. We update in place. We delete. But just adding, just the process of addition and copying and pasting, that is a sign that is not so healthy. And what is interesting is, if I recall the opening of the paper correctly, they basically said, the question we're asking is working with an LLM like working with a senior developer who's mentoring you and has deep knowledge of your code base? Or is it like having a short-term programmer, short-term contractor tear through your code base on an hourly payment rate? The answer is the latter. In this regard, code generating during 2023 more resembles an itinerant contributor prone to violate the dryness of the repos visited. Now, this is not an AI rant. I've just told you where the good stuff is. I've just told you it's in a minority. And we already knew this because it turns out that tools were not the problem. So here's something I tweeted during the pandemic. One of the great things about languages with modern IDE support is that thanks to refactoring tools, legacy code is a thing of the past. It is so great living in the 2020s. We just don't have the kind of legacy code that people used to have. Because, you can just move code around freely. Done. It's not a problem anymore. I envy people coming into programming now. They just don't have to deal with legacy code. They never have to experience long methods, rambling classes, poor identifier names, complex. Yeah, some people responded to this tweet directly without waiting for the tweet after it and the tweet after it. The point is, it was never the tools. The absence or presence of tools was not the issue. It's whether or not people knew how to use them. And again, there's a percentage of people who absolutely have command over this, but the majority of people don't. And you say, refactoring, and they go, yeah, rename. And if you say, well, do you use anything else? They say, yeah, sometimes we use extract method. What about extract class? That's possible. Extract interface? Maybe. Yeah, and we haven't even got to the fun stuff. The point is, it was never the tools. The tools were not the problem. It is to do with first of all, the knowledge of these things, but also the knowledge and the belief that it's possible. If you're in a place of work where this is not normal, then you pick up by osmosis the idea that you don't do this. It's just not a thing. Yeah, it's nobody's fault specifically. Nobody's being willful and being bad. So it's a case of this is just how we do things here. And it turns out that adding tools to just how we do things here does not actually fundamentally change that aspect of the landscape. Now, speaking of barren landscape, let's talk about legacy code. For those who are interested, that's a monolithic architecture. This stuff everybody's complaining about, that's not monolithic. That's monolithic, yeah? That's the kind of latest technology we have in the UK post-Brexit. Yeah, silicon-based, yeah, advanced technology. Classic legacy system. We have no idea who built it, not entirely sure why, but it seems to work twice a year. And nobody's allowed to change it. So let's talk about, so we talked about legacy code. That's not really a metaphor. Spaghetti code is not really a metaphor. Spaghetti code is a description of structure, but it is not a metaphor. If you're trying to suggest to me that spaghetti is bad, I will fight you for it. It's my favorite pasta. Okay? So, oh, this is like spaghetti. Oh, awesome, great. What sauce have you got? No, we're describing structure. We are not describing a kind of a feeling or an economic consequence. That, of course, has not stopped people coming up with all kinds of pasta-based metaphors. You don't want spaghetti. Yes, I do. You want lasagna because it's layered. My favorite one is ravioli, because when people use ravioli, you can tell how old they are. Because when people sort of say, oh, yeah, microservices. Oh, you're quite young. I have seen ravioli. I first heard ravioli in the early 90s as a metaphor for this. And that was objects. And then a few years later, it was components. And then it was services. And now it's microservices. And maybe it's going to be nanoservices next year. Who knows? But the point is, that one seems to change with time. Yeah? Code rot, software decay. These are terms that have been used at various points. These have some of the right suggestion. But they've never really stuck because there is an idea that independently of human action, something will rot. There's the idea that nature takes its course. But that's not how software works. You leave a piece of code alone for a long time, and honestly, the curly brackets don't fall off it. Wow, this code is so old. Some of the ones have decayed into zeros. That's not how it works. Yeah, whereas we have this idea that these happen independently of that. So it doesn't quite have, it has some of the right things, but there's a really big thing in the middle there that doesn't feel quite right. Software entropy, I've already mentioned. Technical debt, that's one. That's the one that's really caught everyone's imagination. We have a much more niche one, unhedged call option. One of my favorite ones is housework. We'll come back to that one. So in terms of origins, the debt metaphor dates back to 1992. It was popularized, so by the end of the 90s, some people, myself included, were using the debt metaphor in describing questions of code and decisions within the code. But it didn't have the name technical consistently. Some people called it technical debt, some people called it design debt or quality debt. It was around the early 2000s, and this is Martin Fowler's blog at the time, 2003. Unfortunately, he's updated the blog since, which is a shame, because actually his blog, his original version was very much a historical document. A lot of people read it, and it had an influence on people's vocabulary. Technical debt is a wonderful metaphor developed by Ward Cunningham, inventor of the wiki. In this metaphor, doing things the quick and dirty way sets us up with a technical debt, which is similar to a financial debt. It's similar, but he's not saying it is a metaphor. We're going to come back to that. But the problem that we have is perhaps partly by suggestion, and Martin repeats it a number of times. He uses the phrase quick and dirty, which is an American English phrase that originated in the earlier part of, well, it was first used at the end of the 19th century, but it really took hold in the earlier part of the 20th century. And it basically means that something has been done hastily. It's temporary. It's not great, but it'll do for now. Please don't keep it around. But it's immediately you're judging the quality of it. You're saying something very negative about it, potentially. So what's happened is that people often assume that technical debt is intrinsically a negative concept. And that is also reinforced by people's common experience of debt. And it's just like, yeah, debt, bad thing. We're going to see that's not really the case. When Ward actually wrote it up in 1992, interesting enough, the reason he used the debt metaphor is that he was describing the problem to a finance company. So he was using their language. Shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. There you go. Everything you needed to know. It's all there. He's not saying it's a bad thing. He's just telling you the conditions under which it works. In fact, perhaps really instead of thinking of it as a debt metaphor, we should think of it as a borrowing metaphor. A subtle difference. Borrowing has two sides to it. I lend and then I pay back. Okay? Yeah, so, or somebody lends, the universe in this case, and then I pay back. There's two sides to it. People are really good at one of those sides, but not so good at the paying back bit. And he tells us, yeah, danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. That's the point. He's not saying it's intrinsically bad. He's referring to a concept of management, how you then manage it. He's actually saying you can take decisions intentionally and say, you know what, we don't have enough time, or more importantly, we don't have enough knowledge at this point to do a good job. Because actually we don't know whether people want this feature, or this is the first time we've used this framework. What's the probability that your code is going to be so awesome that generations to come will point to it and say, that code is the best code I've ever seen? That probability is so close to zero, we might as well call it zero. You've just got to say, yeah, this is the first time we're trying this. Honestly, I'm going to learn stuff. And we should be able to update in line with our learning. And we should account for that. So, we know, by definition, no metaphor is perfect. And there are two common ways in which the metaphor is misapplied. Okay? Assuming technical debt is necessarily something bad. We can do good technical debt. We can have managed debt. We intentionally make a decision. We put a date in the calendar and say, yeah, let's come back and revisit that decision. Or the next sprint, we're going to pay it back. Well, let's review that with more knowledge. Or let's get feedback from the customers. If they don't want this feature and more of it, honestly, that saves us a lot of time. We just delete it. Okay? We write off the debt. That's fine. We eliminate that feature. We eliminate that code. The idea is it's an invitation to a decision. It's an invitation to a path. That's the whole point of this. Debt is the idea that we are taking an advantage, sometimes a timing advantage. And that's often why we will use debt in the real world. So my wife and I had a mortgage, and that was managed, and we got a house for it. That feels like a really good deal. Yeah, obviously better not to have any debt at all, but the point is it was structured, intentional, and we knew the terms and conditions that it applied, and we knew the benefit. We knew the trade-off. It's all about the trade-offs. So it's not intrinsically bad, but the other thing is equating technical debt with a financial debt value. There are tools that will happily tell you, we have analyzed your code base, and guess what? You have 153,000 euros, and 42 cents. Sorry, I'm going to get that right. Maybe it's 41 cents. Who knows? Apparently, it can be so precise and tell you how much technical debt you have in your code. There is a technical term for this. Bullshit. This is pseudoscience. It is not even close to even, and I say this as somebody who takes a fairly dim view of economics. It's not even that good. It's so pseudoscientific. If you say, oh, well, first of all, how do you calibrate it? Yeah? But also, I've got some duplicate code here. Oh, duplicate code is bad. Is it? Always? Sometimes duplication leads to decoupling. There's a trade-off. We duplicate here in order to decouple. Are you accounting for that? How much is that worth? Oh, here's some really bad code in a piece of code that is completely dead. What's the cost of that? The point there is there's so much here. We don't have to worry about this because it's a metaphor. It's not supposed to be an exact financial value. It may cost you, but not in a way that you may be able to recognize as a number. So we're messing up the whole thing here. So let's go back to this thing about effect and cause. Technical debt is often, when people say it, that is an effect they're experiencing. And you know what? If you have a lot of this stuff, it can become a cause. It creates a cycle. But precisely what people really need to say is they need to add one extra word. Remember the silent word I said? Unmanaged. Because if you've got managed technical, if somebody says, oh, we got technical debt on our code base, okay, is that good or bad? What? I have actually done that with a team. They kind of looked at me like, you have no idea what we're taking. Have you come across this term, Kevlin? Sometimes act stupid. It's a really good trick. Sometimes it doesn't work. But in this case, act stupid. It's like, well, oh, is that a good thing or a bad thing that you've got technical debt? Well, yeah, it's a bad thing. Why? Oh, because it's causing so many problems. Why? Because we're not managing it. Boom, there we go. That's the problem. If somebody comes to you and says, hey, we've got technical debt, it's managed. Oh, well done. Congratulations. You know, you've understood it. It's under control. You've worked out how it fits within your workflow, and you've understood its relationship to your architecture and you as a team. Fantastic. It's the unmanaged stuff. The unmanaged stuff is the issue, which leads us to wonder, how did it become unmanaged? Now, I use the terms managed and unmanaged because they are quite neutral. You find there are other terms used. I know that Martin tends to use the term prudent and reckless, but the minute you say, oh, this team's got reckless technical debt, you're almost making a judgment on that team. To be reckless is not a good thing. Well, unless you're a teenager, in which case, of course, it's a quality that your colleagues will, admire in you, perhaps. But the point there is that I want to make this neutral. Teams, there are a lot of reasons that technical debt can be unmanaged. And it's not necessarily, I'm not going to blame the team. We need to understand the situation. So there is a notion here that we need to understand its impact across a number of things. If it's not being managed, then that's going to have problems. That's going to give you problems with staff retention. People are less likely to be happy with the thing that they're working on. For a variety of reasons, their day-to-day doesn't feel good, but one of the most frustrating things is if you know the code can be better, if you don't know the code can be better, you lead a very happy life. Yeah, the boat's always sinking. Yeah, that's just the way it is. But if you know it could be dry, if you know it could be better, that causes you a frustration on a day. We are here, we want to be here, and we could or should be here. That difference is what causes the anxiety or the desire for another job. Security, that's a really interesting one if you want to motivate people. Because it's very difficult to have the claim, we are totally in control of our source. Yes, we understand all the security. Yes, our code base is secure. Oh, what about this piece here? Honestly, we have no idea what it does. Well, hang on, that doesn't sit comfortably with the idea of our, we care about security and we know what it does. So the point there is, it turns out you can start motivating people to manage things and to get budget for it if you need it by talking about security. Compliance, that's another good one. Defects, development, training, pretty much everything. So this is the whole point. The technical debt metaphor is not simply a measure of the specific work needed to repay the debt. This is also how sometimes people evaluate it. I had somebody once mentioned to me, oh, we don't put a monetary value against our technical debt. We've got our technical debt estimated in hours. The amount of hours it will take developers to repay the debt. Well, first of all, that's not exactly your debt because it's an estimate. I mean, I was going to say if I go to an ATM and I take money out, but honestly, I'm really struggling to remember the last time I did that. But let's just say I go and check my bank account. I don't get something saying, "Oh, you've got about this much, Kevlin." It gives me an exact number, so it's not an estimate. But more to the point, it's not about the repayment. It's not simply the hours taken to repay. The whole point of the debt metaphor is the additional time and effort added to all the past work that you've done, the present and the future. That's what the debt metaphor is about. It's the total cost of ownership, not the cost of today's repayment. So, Yvonne Lamb made this observation. My theory of tech debt is that housework is the correct metaphor for the thing we call tech debt, but we can't use it because tech has been made up of people who don't do housework or manage housework being done. Yeah, and it is, isn't it? Because that's the whole point. Your household is just like, well, why are there socks on the floor? Why is the sink kind of filled with stuff? I didn't go to the kitchen to make a mess, but a mess is a side effect of the very act of doing anything that is functional. Breakfast, for example. There's a necessary cost that you have to put extra work in to compensate. Socks naturally gather together and they hunt in packs around the floor unless you catch them and tame them. It takes work and effort and a lot of training. So let's look to past wisdom. I mentioned Ada Lovelace. I'm now going to mention Isabella Beeton, who actually was a contemporary, though I don't think they ever met. Sadly died very young, but she was about 30. Tuberculosis, I think, was one of the suspected causes. But she carefully disguised software engineering wisdom in a book called The Book of Household Management, which was very influential in England, even into the 20th century. And when it came to kitchen advice, she absolutely nailed it. There is no work like early work. Clear as you go. Muddle makes more muddle. Not to wash plates and dishes soon after using makes more work. Isn't it clever the way she gave us the advice, carefully encoded? This is software architectural, and it's encoded as how to look after your kitchen. Clever, yeah? Encryption is what we call it these days, yeah? She coded it there for us to find over a century and a half later. So we have the idea that let us start from nothing and let us build stuff. If we don't clean up the kitchen, then we're going to end up with an awful lot of extra effort. This is a kind of a standard curve. We're all sick to death of exponential curves after the pandemic, but I present you with one nonetheless. The point there is unless you do something to clear it up, you are always going to have to deal with the thing that was there before that's not quite right, even though it's well-intentioned and perhaps has the right functionality. It lacks the integrity and coherence that we want. So we might choose to say, well, every now and then we're going to clean up. And that gives us a benefit. But ultimately, there is the idea of clear as you go. It's the idea of when are you doing this? Always. Now, sometimes it helps to have spring cleaning and put a bit of extra effort in. You know, sometimes you do need to have concerted effort. You know, never just fall into one idea. Make sure that you have a set of ideas you can draw on for your timing. But this also takes us back to maintenance. Maintenance is an action. The problem that we are counteracting is inaction. It's a thing that we do not see. So the wonderful observation from John Seddon, value demand represents the demands customers make for the things they want, things that are of value to them. Now, John Seddon's not a software guy. I saw him speak at a Lean Kanban conference about 15 years ago. He's done work in the UK for the NHS and so on. He's a systems guy, and he kind of looks at the whole thing. And it's a very simplistic model. He breaks down demand into two things, value demand or failure demand. Failure demand is demand caused by a failure to do something or do something right. The idea is, if you are thinking purely from a software development perspective, I am in front of my screen. What is the demand for my time at this point? I am adding a feature. We would like lots of our demand to be that. That's value demand. I am fixing a bug, not so much. That's failure demand, as indeed is that. But it's not just that. I am sitting here trying to understand what I'm looking at. We've lost the knowledge. That's not valuable time. That's failure demand. In fact, it turns out the failure demand is the dominant factor. Think about how much of your day you probably spend not adding value in terms of the activities, compensating for the past, dealing with the problems there. So what we're dealing with is the fact that we missed something. There's a thing that we did not see. It is not an act, it's an absence of act. It's a neglect. There's a want of attention to what ought to be done. The fact of leaving something undone or unattended to. Negligence. In other words, we just didn't see it. We didn't notice it. And what are examples of this? Well, there's quite a few. Things that we might not do. Not refactoring before change. Not refactoring after. Not testing. Not reviewing code. And all of these things, they're things we don't do, and they add a cost. It's either a knowledge cost or it's a stuff cost. It's an amount of stuff that we end up with. Not recording decisions. Why is the code like this? Is it safe to delete this, or do we have to work around it? Not revisiting decisions. Not updating technology. Not turning down the noise. You've got noisy logs, noisy builds? Well, they're no use, because you've learned to ignore them. Yeah, we neglect them. There's loads. It's all examples. So many people would say, well, you know, what we're describing here is technical work. And people often, when they use that terminology, say, oh, technical work. Yeah, but my product owner is going to talk about feature work. And it's presented as a false dichotomy. You can do feature work or technical work. Well, I have news for you. Feature work is technical work. Because in a software system, everything is made of technical stuff. There is nothing else. There's no pixie dust. If somebody wants a feature, if there is pixie dust, honestly, go with that. If there is technical work if somebody wants a feature and say, do you want me to do that in a technical way or a non-technical way? The point is, it's all technical work once we are in that space, because features are made of software. So, this is the point. I return you to this. What is lacking here is maintenance. The question is, when do we do maintenance? Well, now. Yes, you can do puns across languages. Now. So I will close with a quote from Annie Dillard, the author. How we spend our days is, of course, how we spend our lives. The things you do today are those things. All too often, we have these ambitions. After the next release, it'll all get better. I'll put a bit more extra time. We'll repay the technical debt. After the next minor release, major release, after the companies merge, after whatever it is, you're creating a goal that it will never arrive. Something else will happen at that point. You know this. This is the rest of your life. The point is, it doesn't take much. Just do a little thing, 5 minutes, 10 minutes. Have a chat with somebody, communicate about something. Make a small change. Immediately that creates, importantly, an awareness. And that's the first thing. You have to see the absence of the thing that is being done. Learn to see the neglect. It's very invisible, and it's not because people are being bad or stupid. Normally, we're in technology, we're quite smart. But we are very busy, and our attention is everywhere. So you have to learn how to see this, and then learn how to respond. Thank you very much.